Now, combination of the capacitors. Capacitors are connected two ways in electrical circuits. There are two types of combination: series combination of capacitors, parallel combination of capacitors. How two capacitors are connected in series? Example: now your two capacitors are connected one end to the another end. Such a combination is called series combination. Example: parallel combination of two capacitors here. The right terminals are connected to one point, so left terminals are connected another point. So now we have series combination of the capacitors. So here C1 and C2 are two capacitors. When two capacitors are connected from one end to the another end, such a combination is called a series combination. So the first capacitor C1, second capacitor may be C2. The two capacitors are get charged using battery potential. The first capacitor may be charged plus Q. So minus Q. One plate may be positive charge plus Q. Another plate negative charge minus Q. Second capacitor also get charged, same charge plus Q and minus Q. In series combination, all capacitors are get the same charge. Now potential difference across first capacitor C1, V1. V1 is a potential difference across the first capacitor. V2 is a potential difference across the second capacitor. So V equal to V1 plus V2. The potential difference across the combination is equal to sum of the potential difference across each capacitor. This is a series combination of capacitor. The mathematical formula for series combination of capacitor: 1 by Cs equal to 1 by C1 plus 1 by C2. If C1 equal to 1 microfarad, C2 equal to 2 microfarad, now you will calculate effective capacitance. Effective capacitance decreases in series combination. So then effective capacitance decrease, what about voltage? Voltage is increased. Now formula Q equal to C into V. So V equal to Q by C. In series combination, charge remains constant. Same charge for all capacitor. Then formula V inversely proportional to C. But in series combination, total capacitance will decrease, voltage increase. So this is a series combination of the capacitors. Second one, parallel combination of the capacitors. Now two capacitors are there, C1 and C2. The left terminals of the two capacitors are connected to one common point. The right terminals are connected to another common point. So how they are connected? Parallel plate capacitor. The two capacitors are connected two common point and two common terminals. So C1 and C2 are two capacitors are charged with a battery potential using DC battery potential. So the first capacitor may be charged Q1, second capacitor charged Q2. So total charge equal to sum of the charge on each capacitor. But voltage across each capacitor is same. In parallel combination, voltage across or potential difference across each capacitor is same. The mathematical formula for parallel plate capacitor: Cp equal to C1 plus C2. So total capacitance increase. When total capacitance increase, whatever voltage, so V inversely proportional to C. C increase, capacitance increase, voltage decrease. Now, what purpose two capacitors are connected in series and parallel? If two capacitors, the same value of two capacitors are connected in series, effective or total capacitance decrease, voltage increase. The same two capacitors are connected in parallel, total capacitance increase, so voltage decrease. Now, series combination of capacitors. This is a 3 marks question. Derive an expression for effective or equivalent capacitance of two capacitors connected in series. So this is a series combination. Now we have two capacitors, C1 and C2. C1 and C2 are two capacitors are connected from one end to the other end. Such a combination is called a series combination. Now here C1 and C2 are two capacitors are connected in series, and this combination is connected to battery. Battery is a source of EMF, or a group of cells is called battery. Now C1, C2 are get charged with the help of using battery potential. The first capacitor C1 is charged. The first plate charge plus Q minus Q. Second capacitor may be charged plus Q and minus Q. In series combination, all capacitors get same charge. V1 is a voltage across the first capacitor C1. V2 is a voltage across the second capacitor C2. The potential difference across the combination is equal to sum of the potential difference across each capacitor. So V equal to V1 plus V2. So V equal to V1 plus V2. Potential difference across the combination is equal to sum of the potential difference across each capacitor. Here V equal to V1 plus V2 is the equation number 1. Now potential difference across the first capacitor C1. The mathematical formula V1 equal to Q by C1. V1 is a potential difference across the first capacitor, Q by C1. So V1 equal to Q by C1. Potential difference across the second capacitor, V2 equal to Q by C2. V2 equal to Q by C2. Now substituting for V1 and V2 value in equation 1. So now from equation 1, substituting for V1 and V2 value. So V equal to, so V1, what is V1? Q by C1. V2 equal to Q by C2. What is the Q? Q is the charge. The charge on each capacitor is same in series combination. So V equal to Q take outside. So 1 by C1 plus 1 by C2. So this is equation number 2. This is equation number 2. So after the two capacitors are replaced by connecting a single capacitor, the single capacitor which produces the same effective value of charge and voltage, such as effective capacitance or equivalent capacitance, or one more name, total capacitance. In series combination, total capacitance or effective or equivalent capacitance, the symbol CS. CS is a effective or total or equivalent capacitance in series combination. So this capacitor also connected battery. So the potential difference across the equivalent capacitance, now formula V equals what? Q by charge Q by. So here C1 C2 are there, but here mentioned what? CS. So CS. Equation number 3. This is equation number 3. So potential difference across the capacitor CS. So V equal to Q by CS. Q is a charge. CS is a effective or equivalent capacitance, or one more name, total capacitance. So then V equal to Q by CS, equation number 3. Now comparing from equation 2 and 3. From equation 2, V equal to Q 1 by C1 plus 1 by C2. Equation number 3, V equal to Q by CS into 3. Now comparing from equation 2 and 3, Q by CS equal to, so here what? Q into 1 by C1 plus 1 by C2. 1 by C2. Now here 2 cancel left side and right side. The final 1 by CS equal to 1 by C1 plus 1 by C2. This is the expression for when two capacitors are connected in series. Effective or equivalent capacitance of two capacitors in series, 1 by CS equal to 1 by C1 plus 1 by C2. Define effective or equivalent capacitance in series combination. Now mathematical formula 1 by CS. So 1 by CS means the reciprocal of effective or equivalent capacitance of a number of capacitors connected in series is equal to sum of reciprocal of individual capacitances. So this is a series combination of a capacitors. Parallel combination of capacitors. Derive an expression for effective or equivalent capacitance of two capacitors connected in parallel. This is also 3 marks question. Parallel combination of capacitors. How two capacitors are connected in parallel? When two capacitors are connected in parallel, two common terminals or two common points. Now here C1 and C2 are two capacitors are connected in parallel. Now the two capacitors are get charged with help of battery potential. The first capacitor may be charged plus Q1 minus Q1. Second capacitor charged plus Q2 and minus Q2. The total charge on the combination equals sum of the charge on each capacitor. The total charge on the combination equal to sum of the charge on each capacitor. And V is potential difference across the combination. In parallel combination, potential difference across each capacitor is same. Now the total charge Q equal to Q1 plus Q2. This is equation number 1. Now charge on the first capacitor. So Q1 equal to C1V. Q1 is the charge on first capacitor. C1 is a capacitor. V is a potential. Same potential for both capacitors C1 and C2. Now charge on the second capacitor. Q2 equal to C2V. Charge on the second capacitor. Q2 equal to C2V. Now you have observed two equations V and V. Same potential, same voltage for both capacitors. Therefore, in parallel combination, the potential difference across each capacitor is same. So from equation 1, now substituting for Q1 and Q2 value. So Q equal to Q1 plus Q2. So Q equal to Q1 C1V plus C2V. Now here V is a voltage. In parallel combination, potential or voltage across each capacitor is same. So Q equal to, so we take common C1 plus C2. This is equation number 2. So after the two capacitors are replaced by connecting single capacitor. The single capacitor which delivers the same effective value of charge and voltage. So in parallel combination, a effective or equivalent capacitance or total capacitance symbol CP. Now CP is a effective or equivalent or total capacitance in parallel combination. This symbol represents total capacitance in parallel combination CP. Now charge on this capacitor Q equal to Q1 equal to C1V. Here Q equal to C1 plus what? CP is there. So CP and voltage V. This is equation number 3. Now comparing from equation 2 and 3. From equation 2, Q equal to V C1 plus C2. And equation 3, Q equal to CPV. Now CPV equals equation 2 V C1 plus C2. Now V cancel. Finally CP equal to C1 plus C2. CP equal to C1 plus C2. So CP equal to C1 plus C2. This is effective or equivalent capacitance when two capacitors are connected in parallel. CP equal to C1 plus C2. Define effective or equivalent capacitance in parallel combination. The effective or equivalent capacitance of a number of capacitors connected in parallel is equal to sum of their individual capacitance.